Welcome back. In this second part of C tokens, we mainly talk about constants. Towards the end, I will discuss about strings and operators. We know that one or more C characters are combined in meaningful manner to form C tokens, and these are the smallest building blocks of C language. And we already know the classification like keywords, identifiers, constants, strings, special symbols and operators. In the previous session, we discussed about special symbols. In this session, we talk about constants. Constant is a value which will not change during the execution of the program. And in C language, we have different types of constants like numeric constants, character constants, even we have string constants and symbolic constants. The symbolic constants will be discussed in detail under preprocessor directives. So, we are not discussing in this particular session. So, first we start with the numeric constants. The numerical constants are of two types. One is integer and the other one is, my dear friends, you all know integer constants, same integer constant. It should have at least one digit. It should not contain any decimal points. No blank spaces or commas are allowed. It can be positive or negative. By default, we take it as positive. So, we can take some examples for integer constant. This is an integer constant. Even this is an integer constant. If you do not put any sign, by default it is positive. We can also have negative integer constants. And C integer types comes in different types, different sizes. Okay. Of course, they are like short, int, long, and if you take latest versions of C language, okay, we generally restrict ourselves to 89 or 90 standard, but if you take latest version, we also have long additional types also, but we restrict ourselves to the short, int and long type only. So, we can take short. See, the shortest or short integer takes 2 bytes. 2 bytes means 16 bits. Then we have integer. See, the size of integer varies from compiler to compiler. Okay. So, in my compiler, the size of integer is 4 bytes. Maybe in the old compilers, it may be 2 bytes. Okay. Because of that, you have to depend on the compiler to check the size of these fellows before using them. Okay. So, I am using 4 bytes here, and even long in my compiler is 4 bytes. Now, 16 bits means actually you can encode 2 power 16 numbers, but if you take from negative to positive, because in between 0 is there, so the numbers range is from minus 2 power 15 to plus 2 power 15 minus 1, one number less because 0 is included. But if you are considering only non-negative integers, you are going from 0 to 2 power 16 minus 1. If you want to see these numbers, okay, this 2 power 15 is minus 32,768, whereas 2 power 15 minus 1 is 32,768 minus 1, that is 32,767. So, the range is from minus 32,768 to 32,767. And here if you take non-negative, then it varies from 0 to, it is 65,530. Okay, you can use calculator to get those values. And when it is 4 bytes, as I told you, 4 bytes means it is equal to 32 bits. You can actually encode 2 power 32 numbers. But when you are going from negative to positive, it varies from minus 2 power 31, that is half of that. 2 power 32 by 2 is 2 power 31. Negative side minus 2 power 31, but positive side, because 0 also to become, but 0 is neither positive nor negative, but you have to include 0 also in between. So, one number will be less. So, minus 2 power 31 to plus 2 power 31 minus 1. Okay. And when you go for only non-negative numbers, you can encode from 0 to 2 power 32 minus 1. Of course, if you want to note these numbers, 2 power 31 is 2147483. Even I do not remember this, sir. Okay. Whatever my calculator is saying, I am writing. It is better to remember that way. Okay. And from here to 214748364, 1 less than, that is 64. And it is 2 power 32 minus 1 means it is going from 0 to this is a big number 4294967,295. If you want, you can remember. I do not recommend. At least these numbers, if you remember, it is good for health. These two numbers, because you can get it by just subtracting 1. These two numbers, if you remember, that is good for health. Okay. These big numbers, okay, it is up to you, my dear friends. Now, we are having macros which defines the characteristics of integer types, okay, available in this limits.h. Okay, macros defining the characteristics of integer types are available in this limits.h. So, these are called macros, short underscore min, short underscore max. So, these will give you the minimum and maximum value of each of these types, like short, what is the minimum value, what is the maximum value, and unsigned short, u short, that is USHRT underscore max. So, these are the macros, the preprocessor macros, okay, which are defined in the limits.h. So, if you include limits.h in your file, you can get those values. Okay, you can see short minimum value is minus 32,768, that is what exactly we used, and maximum is 32,767, because it is 2 bytes, that is the minimum and maximum. Obviously, you know that value. And unsigned means if you are going from only 0 to highest value, that will go up to 65,530. Same is the case for int min, int max. Int min is going from what? Minus 2 power 31 to plus 2 power 31, minus 1. That is minus 2147483648 to 2147483647, 1 less than that. Am I clear? And unsigned means it goes from 0 to 2 power 32 minus 1. Of course, long is also taking same 4 bytes, the values are exactly same as integer range, my dear. Okay. So, even if you are taking integer constants, if you want to print them, if they are in the same range, you can print them properly in your compiler or in your compiler or in your program, my dear friend. Okay. When you run the program, if the values are in that particular range, any integer constant you want to print with the proper conversion specifier, if it is within that range, it will be properly printed. Otherwise, you get some unexpected values. We will try to discuss more about it when we talk about data types, my dear friend. Now, integer types again can be obtained in 3 different ways, like regular decimal manner or octal, yeah, hexadecimal. You call it as base 10 system. This is base 8 system, whereas hexadecimal is base 16 system. So, you can represent the integer constant in all the 3 systems, my dear friend. So, for those who are having difficulty in conversion from octal to decimal or decimal to octal and decimal to hexadecimal and hexadecimal to decimal, let me give you simple examples first of all. Then we will see how to print these octal numbers and hexadecimal numbers in C language. So, decimal to octal. Let us take one simple example. Consider the number in decimal system. See, by default, when it is in decimal system, we call it as base 10 system, we write base 10. Of course, when you understand, do not have to write it, but here because you are converting from decimal to octal, better write down in that particular system. Now, I want to convert from decimal to octal. See, when you want to convert from decimal to octal, simply take the number, okay, start dividing with 8. 8 ones 8. Now, 15 minus 8 is 76 you are going to get, okay, 8 nines 72. So, remainder is 4, remainder is 4. Then again you take 8, 8 to 16, remainder is 3. Remember my dear friends, it should be less than, you get the numbers less than 8, that is 0 to 7 numbers only you are going to get. So, this is your number my dear friends, you just read it from here to here, this is your octal number or octal equivalent for that given decimal number. So, you can write it as 234 base 8, that is 156 in base 8 is equivalent to base 10 is base 10 is equivalent to 234 in base 8. Hope you understand. You can take different examples my dear friends and you can convince yourself. Now, we can also check the reverse process from octal to decimal. How to convert from octal to decimal? Let us take the same number 234, convert into decimal format. See, when you want to convert any different number system to decimal number system, what we need to do is you consider the number first of all, because it is base 8 system, the first position is for 8 power 0. Let us use a different color. Then next position is 8 power 1. So, you generally call it as units, tens, hundreds like that. No? So, here it is units, 8s, 8 squares like that. Similarly, in base 10 system you have units, tens, hundreds means 10 square, okay, thousands means 10 cube. Same here, base 8 system means units, that is 8 power 0, ones, units, tens, tens you say here you have to say 8s, then 8 square, okay, you can say units, okay, 8s, 16s, 32 like that, that is power of that, not 32 sir, 8 cube, next one is 8 square like that it continues. Now, how to convert into decimal system sir? Simply you have to multiply this with corresponding number, multiply this with corresponding number, multiply this with corresponding number and you have to add them. Am I clear? So, let us do that. So, I repeat once again what we need to do sir, we simply multiply this with the corresponding number, multiply with this corresponding position, multiply this with corresponding position. So, what you are going to get 8 square 64 into 2, 8 into 3, 8 power 0 is 1 into 4. So, the result is 2 4s 8, 2 6 12, 8 3 is 24 plus 4. So, which is nothing but 156 is the decimal equivalent for the given. Okay. So, you can try different examples my dear friend, the idea is the same. You can take any number, but remember the number should contain digits from 0 to 7 only. If it is in octal system means it should contain only digits from 0 to 7 only. See, some people what they do, they try like this, it will fail because 9 you cannot have in a octal system. Please note that point. Okay. Definitely you take any example, any number, you will definitely can convert into decimal system. From decimal to octal system you can convert by this process. Similarly, let us try from decimal to hexadecimal system. Decimal to hexadecimal. Hexadecimal means base 16 system. See, in hexadecimal we have the following digits. Okay, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to here same, but 10 we represented by capital A, 11 capital B, 12 capital C, 13 capital D, 14 capital E, 15 capital F. Either you can use capital A or small a sir. This 10 is represented by A, 11 is represented by B, 12 is represented by C like that. Okay, please remember these digits for hexadecimal system. Okay. Now, let us consider the example. Let us take a number, same number, let us consider 156 in base 10 system. Let us try to convert into hexadecimal. Divide with 16. You know 16 9s 144. So, how much is remaining sir? 12 is remaining. See, this remainder 12, 12 means this is 10, this is 11, this is 12, 12 is C. So, you can write C. But it is already less than 9, less than 16 means done, you already got the number. So, 9C is the number. What is the number? 9C is the number. So, the equivalent hexadecimal is 9C my dear friends, base 16. Hope you understand. You can take any different example, my dear friends, you can get the answer. You can try any different example like 178 you can. This is in base 10 system, you want to convert into hexadecimal. 16 ones, okay, 18, 16 ones, 2 remaining. But 11 means already less than 16 done. 11 means what, sir? 11 means you have to write 11 is what? B2. It is B2. B2 in hexadecimal. You can also try the reverse process from hexadecimal to decimal system. Let us try this 9C. As I told you, same logic you have to apply, sir. First write the number, units, that is 16 power 0, ones, that is 16 power 1. Now multiply these fellows with the corresponding numbers. You have to multiply this with this and this with this. And C is 12, remember. So 16 into 9 plus 16 power 0 is 1 into C is 12. So if you simplify, obviously you get 150. So we can get from hexadecimal to decimal and decimal to hexadecimal. Similarly, decimal to octal, octal to decimal. Okay. So this is a simple process of conversion, my dear friend. Now let us write down a simple program to print decimal, octal and hexadecimal constant. Okay. So I start with hash include stdio.h. I am including standard input output library. Then I am having the main function block. Okay. This is my main function block. I just use the printf function because I just want to print the constants, right. So let me start with the printf function. So the octal representation of, see what I want to print is the octal representation of 156 is 234. We already seen the example. So I want to send that argument. So I will write the octal representation of percentile D is, this time I want to print it in octal format. For that the conversion specification is percentile O. Okay, I just use \n so that remaining part can be printed in the next line. Now here I send 156 for first percentile D. For the second one also I will send 156, but this will be converted to octal and that will be printed, my dear friend. So the expected output for this line is, of course, the octal representation of that entire blah 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 will be printed. What is printed is 156 is, because you know 156 octal representation is 234, that will be printed. Okay. Now next line I want to do the hexadecimal representation or hexadecimal constant print. So let me copy paste this and change this statement accordingly. The hexadecimal representation of percentile D is, see for hexadecimal the conversion specification is percentile X, or you can also use percentile capital X. If you use small x, small ABC will be printed. If you use capital X, capital ABC will be printed for 10, 11, 12, etc. Rest of the story is same, but please remember for the first percentile D this 156, for percentile X this 156, for the third one you not kept any argument, that is okay, it will not give you any error, but it may give you some unexpected answers. So please be careful. So you have to keep argument corresponding to that. Okay. So the expected output in this case is blah 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 156. We already know na, for 156 what is the hexadecimal representation? 9C if you write with percentile small x, or okay, here it is get this is, and here or you should get 9 capitals. Let us run this and verify. And you can see that the octal representation of 156 is 234 and the hexadecimal representation of 156 is 9 small c or 9 capital. Okay. So let us continue this. Now what I want is, I will give the argument in octal and hexadecimal form, but I want to print it in decimal format. So let us see that. The decimal form of, see actually the argument should be given like 0, 2, 3, 4. If it is octal number, we have to keep 0 before, so that we will understand it is a octal constant. So, we send that as argument, and that argument we want to convert it in decimal form. So, the argument we have to supply is 0, 2, 3, 4. If you write 2, 3, 4, it will misunderstand. Please be careful and end this line with a semicolon. Now, similarly, I try to take a hexadecimal number. The decimal form, I will take one hexadecimal number. So, if you already know the number whose decimal format is known, you write down that and verify. Here I know one number which I already calculated and kept. So, let me try that. So, the number which I kept is 0x9ab is what? So, I will supply that argument 0x9ab. See, actually you can use small ab or capital AB, it will be printed. See, if you want, you can try both 0x9ab. Do not mix and match, sir. Either use small letters or use capital letters. So, I need one more percent LD now. See, for this I have 1% LD. For this also I have to keep 1%. So, either this or again percentage. Let us run this and verify what happens. Okay, 9xab, there may be some error, let us verify. 0x correct only, 9ab, what is 0xab first use in this one. Okay, this is 0 na, I written O, that is why it is saying Babu, you have to be careful. Instead of 0, if you print O, it will say O, because it is considering it as a variable, but you not defined any variable in the program. So, now you will get the output. The octal representation is this one, we already verified. Now, the decimal form of 0, 2, 3, 4 is 156, and 0x9ab, whether you write 0x9ab or 0 capital X9ab, the same answer will be printed, that is 247. See, if you know any other number, you just need to write prefix 0x or 0 capital X. Write 0, do not write O. Am I clear? So, then it will be printed properly. Okay. The next one is floating point constant. See, floating point constants can be represented in two forms. One is fractional form, the other one is called scientific. The fractional form is what we regularly write. Okay. So, it will have floating point number represented in fractional form has an integer part followed by a decimal point and a fractional part. We all know this particular method, my dear, 15.3. That is your regular fractional way of representing real numbers, okay, floating numbers you can call. The other one is scientific notation. In the scientific notation, we have a mantissa. The mantissa part can be integer or a floating point followed by E, which represents power, nothing more than that, followed by the exponent, what is the power we are having. So, exponent must be integer only. This exponent must be integer only, it can have optional plus or minus sign. Even the mantissa, it is either integer or floating number with optional plus minus sign, my dear friend. Let me give you a simple example for writing this floating point number. So, if you write 2e power 4, the meaning is 2 into 10 power 4, that is the meaning of that. When you write 2e power minus 4, the meaning is 2 into 10 power minus 4, that is the number. So, that number is represented in that particular scientific form. And what about this minus 2 into 10 power 4? And what about this minus 2 into 10 power minus? See, instead of this 2, you can have fractional number also, no problem. Okay. So, this is your fractional constant. See, C provides 3 types of floating types, okay, or 3 floating types corresponding to different floating point formats. So, they are float, double and long double. See, long double we are not discussing because they are used for advanced applications. In our basic applications, we just come across this float and double. The float is called single precision floating point type, whereas double is called double precision floating type, whereas long double is extended precision floating type. My dear friends, by default, if you write any floating or floating type, that is considered as, by default it is double type only. by default floating point constants are stored as double precision numbers only. So, if you want to store them as floating numbers, you have to do something called typecasting. We will discuss later. Okay. Now, the C standard does not state how much precision the float double and long double provides. See, here we said single precision, but single precision means how much. C standard does not tell you anything about it. Okay, it depends on which architecture we are using and which for standard you are following. But most of the modern computers follow the IEEE standard 754 for storing floating point number. Based on that, generally the floating point single precision may be around 6 to 7 digits precision, whereas double precision is around 15 to 16 digits precision. The extended double varies from compiler to compiler, my dear friends. So, I am not explicitly mentioning, because this is not mentioned by C standard. So, you cannot depend on your C standard or a particular example, because how the floating point is stored, it depends on that particular criterion, my dear friend. Please remember. And if you want to know, okay, your machine, how many digits precision the float is having, how many digits precision double is having, and how many digits precision long double is having, you have to use this float.h. So, macros defining the properties of this float types are defined in this float.h. So, if you include in your file and if you use this macros float underscore minimum, you know minimum and maximum values for float double, even for long double also you can know it, and also the how many digits precision. So, in my machine, float is having 6 digits precision, double is having 15 digits precision, whereas long double is having 18 digits precision. So, do not worry if you are not able to get it, just use float.h in your file. Try to check in your machine how many digits precision you are having. See, roughly around 6 to 7 digits floating point will give you a correct answer. More than that, you cannot get the exact answer, my dear friends. Up to 7 digits, you can get exact answer. More than that, floating point numbers may not give you the exact answer. But directly do not take a number and print it, my dear friends, because for floating point we use the conversion specifier %f. For double we are using %d, and for long double %ld you are going to use, okay, LF, sorry. For double I think we are going to use LF. Again we have this you know, percentile E to represent it in exponential format. Percentile E is used to represent in exponential format, my dear friend. Please note that. Am I clear? Because these are integers only, I am using percentile D. These numbers 6, 15, 18 are integers. So, we are using percentile D only. Okay, directly that number, what is that number, how many digits precision, you can directly get that with percentile D only. So, this is about floating point constants. Now, the next type of constants are characters. A character enclosed within a pair of single quotes. Okay, it can be B, even numbers also, even this is a character. So, any character which is written within a single quote is considered as a character constant in C language, and each character is associated with a unique integer value called ASCII value. So, for capital A, the ASCII value is 65, then capital B next number 66, capital C 67, like that it goes up to capital Z ASCII value is 90, okay, and small a ASCII value is 97, similarly small b 98, and so on up to small z it is 122. 0, see 0 character ASCII value is 48, 1 character ASCII value is 49, and 9 character ASCII value is 56. So, this is how these fellows are stored. So, for each character we are having a unique integer value associated, and that integer value we call it as ASCII value, American Standard Code for Information, okay, that is the full form of ASCII, right. My dear friends, we can print character with conversion specifier percentile C. So, we can use this conversion specification percentile C to print the character. My dear friends, if you observe the first example, in the printf, if you see percentile C, okay, conversion specification, it looks for the argument. The argument is character in a single quote. So, the character is printed. Again, if you see percentile C, but here this time you not given the character, but you given the ASCII value, but the ASCII value is converted to character. 65 means A. Now, look here, you given percentile D, but you given here character. So, you are printing the number, percentile D means number. So, you are going to get the number. What is the number? The ASCII value of A, 65 is printed. Okay, you can experiment with more examples. Is the idea clear? Next, strings. Of course, we discuss strings in more details after pointers, but here I am just discussing string constants only. Okay. See, sequence of characters within the double quotes are called string constant, and every string by default terminates with a null character. See, even though you write like this, in the memory it will be stored MacsGate with \0, my dear friend, that it is by default terminated with a null character. Of course, it is not visible, but it is stored with \0, my dear friends. Every string terminates with a null character, remember. Whether you write MacsGate, whether you write C programming, any string within the double quote, in the memory it is stored like C programming end with \0, that is null character. See, you can print the string using conversion specification percentile S. That is, we use percentile S as the conversion specification for printing string. So, percentile S, you can write the string constant. So, it will identify the string constant and it will print it as it is. Of course, here MSG, even this is a string only. So, that whatever string is there, percentile S, when you are having the conversion specification percentile S, it will search for a string, and whatever string is there, that will be printed as. Am I clear? So, dear students, welcome to. The next one is operators. My dear friends, the operators are discussed in more detailed manner in operators and expressions chapter. Okay, here I am just trying to introduce operators. An operator is a symbol that tells the computer to perform certain mathematical or logical manipulation between the operands. Okay, we have different types of operators like arithmetic operators, relational operators, logical operators. Now, let us see a simple program to illustrate the basic operation. As usual, we start with hash include stdio.h. Okay. Now, this is my main function block. So, here I am just printing the basic operation between two integer constants. Okay. So, let me write down that printf. Okay. So, I just want to print the percentile number, percentile D, and of course, every time I write \n. So, here what I want to print is, I just take two numbers, I will just take 5, 2. I check what is their sum, what is their difference. So, I can just use \t, no, so I can print all of them in a single line. Then next percentile D, \t, percentile D, \t, percentile D. Okay. The basic addition, subtraction, multiplication I write in a single line. 5 minus 2, 5 into 3, and 5 divided by 3. You can write 2 or 3, whatever numbers you want. You can take different numbers if you want. Let us try same numbers. You can try different numbers, no problem. And we also have one more beautiful operator for integers, that is percentile operation. Okay, and that is percentile D, and that is 5 percentile 2. What percentile will give you the remainder when you divide 5 by 2? It should give you the answer 1. Okay. So, let us see the expected output for this, my dear friend. 5 plus 2 should give you 7. Then with tab you should get okay, this, let us write down comments. You should get 7. Then 5 minus 2 you should get 3. 5 into 2, 10. 5 by 2, see the quotient you are going to get 2 times. okay, and here you are going to get the remainder, that is 1. Okay. Let us run this. Wow, 7, 3, 10, 2, 1. You also have other operators like logical operators. Okay. So, let us try those logical operators. So, what I want to print is, okay, I will just use percentage backslash t, percentage d, backslash t, okay, backslash n, let us say. Here I want to check whether 5 greater than 2, 5 less than 2, yeah, 5 equal to, see, for equal to we have to use double equal to set. So, because we use 3, try one more, percentage. So, you should have number of arguments equal to number of conversion specifications. Please remember, you can verify this. Okay. We also have other operators like logical and logical OR operations. Okay. So, let me use the logical AND and bitwise and bitwise OR operators also we have. I will just use one. Later on when we discuss about them, we will understand this more. Okay. So, let me write down here what I want to do is logical AND. See, logical AND means if both are true. See, normally any non-zero value is considered as true. So, true and true, it will give you true, that is 1 will be printed. Whereas we are having bitwise AND operator. The bitwise AND operator, you have to write 5 in the binary format, 2 also in the binary format. So, what happens, the corresponding bits, if both are 1, then that is taken as 1. Okay. So, for example, you all know, of course, here I cannot write. Okay, let me just write here and check semicolon. See, for example, 5 you all know, right, 4 1. So, it is like 0 1 0 1. Okay. Of course, there will be leading zeros. Okay. And for 2 it is like 0 0 1 0. See, only, of course, there is nothing is matching here. See, first position, if you consider the first position here, it is 1 and it is 0, they are not matching. Second position, it is 0, it is 1, they are not matching. So, the logical, I mean the bitwise AND operator will give you the answer G. You can verify all that, my dear friends. Okay. So, the answer here is, see, for first one you get one answer, whereas the second bitwise AND we will discuss more in the operator session, but here I just want to give the basic understanding of operators. So, here you should get 0 answer. Okay. And here what you should expect, 5 greater than 2, that is true. So, you should expect the answer 1, 5 less than 2 wrong, 0 answer, 5 equal to 2 also 0 answer. So, let us run this and verify. So, you can see 1 0 0 and 1. So, this is about the basic operations done on constants. Later on we try to learn about variables, how to create variables and how to perform these operations, not just single operator, multiple operators on different variables. Thank you.